Hello everyone, welcome to the virtual open day with the School of Computer Science at the University of Lincoln. Hello everyone, hello Phil, hello Mark, how are you guys doing?
Hey Oliver.
Yep, good.
Doing well.
Good, thanks.
Good, thanks, that's fantastic. All right, so my name is Oliver Simonezic. I am your host today for the virtual open day at the School of Computer Science. I am a lecturer who teaches game programming and physics simulation, game development, basically a lot of programming. I'm also the admission tutor, so you probably have already exchanged a lot of messages with me, a lot of emails to discuss the admission process at the University of Lincoln School of Computer Science. And my background is, I mentioned a lot of programming. I'm doing a lot of programming, teaching a lot of programming. Also got a lot of interest in the research of digital board games, a lot of interest in crowd simulation, crowd AI, indoor location systems. My contact email, if you've got any question, is on the screen. At some point, I will put it in the chat as well, so it'll be easy for you to contact me if you've got any questions. But also, if you've got any questions generally about what we're doing, about this tour, about what we're talking about today, feel free to interact with us in the chat. Phil is there, Mark is there, I'll be there as well, answering as many questions. Answering as many questions as possible. I've been answering all the questions that you guys are asking us. And again, I'm not alone today because I've got William Oldham who will pop over in a couple of minutes to do a small tour of the INB building, because that's currently where I am. I'm currently live on campus at the University of Lincoln, and we're going to showcase you the building where the School of Computer Science is located. I'm also got Mark Doughty, who is the program leader of computer science, and Philip Carlisle, the program leader of games computing. And they will introduce themselves in their own section. By the way, we're presenting computer science first, followed by games computing. But the two programs are very interlinked with each other, as Phil and Mark will talk about in a couple of minutes. All right, welcome to University of Lincoln. I've got a picture here on screen of our campus, which is located more or less in the center of Lincoln. Lincoln, well, I may be biased because I lived here for over 15 years. It's a beautiful city. Absolutely love it. It's not too big, it's not too small. The campus is in walkable distance of the city center. There's plenty of shops. It's a brilliant location. The building itself that I'm situated in, that the School of Computer Science is situated in, is right here. And it's called the INB building, the Isaac Newton building. And it's a new building that was completed a couple of years ago in 2017. And I'm going to show you a little section of it in a couple of minutes as well. Lincoln itself is a beautiful city in the East Midlands, located right here, not too far from York, Leeds, Sheffield, Nottingham, Peterborough, Norwich, and we get a lot of students from actually all over Britain. And the cathedral is visible from as good as everywhere in the city. It's a beautiful location. Cathedral itself is really nice. It's perfect, fantastic place to walk around, discover the history of Lincoln, discover the campus. If you haven't visited the city yet, I really recommend to pop over, have a look around, explore the campus, have a tour with our guides. Absolutely beautiful city. Also, Lincoln, interestingly, is becoming more and more popular in the media itself, especially in video games. There's, for instance, an upcoming RTS title that will take part of it in Lincoln. There's open world games that take the Viking history of Lincoln, try to recreate it. And of course, there's a couple of simulation games where Lincoln can be flown over. It's fantastic to see Lincoln more and more in popular media. Also, I mentioned we're currently in the INB building. I've got a couple of pictures of how the inside of the INB building looks like, a picture of our labs, a picture of the atrium, a picture of our PCs. But again, Will Oldham will showcase you the building in a couple of minutes. I keep saying a couple of minutes a lot. Anyway, don't be afraid to interact with us. Don't be afraid to ask questions in the chat or to contact me over email. Don't be afraid as well to follow us on Twitter. If you just search for URL University of Lincoln Computer Science, You'll find our Twitter pages. We'll keep posting new stuff, new videos all the time. We also got a popular Facebook page, a YouTube account with plenty of videos, and of course our website where we talk about the program and about university in general. I mentioned the YouTube page. I really recommend to have a look at our YouTube page because we've got plenty of talks uploaded on there that you can download and watch. So for instance, we had lots of talks during the British Science Weeks. Just a couple of examples. We talked about writing secure multiplayer games, introduction to shaders in Unity. We talked about crowd AI. Well, I talked about crowd AI. We talked about cloud computing and all that kind of stuff. There were also talks about robots in the wild, what is player experiences, board games modalities, games and computer science programs. There's plenty of stuff on our YouTube pages. You can also watch our previous Open Day broadcast on YouTube. So don't be afraid to go to YouTube, search for computer science, University of Lincoln Computer Science, and you'll find our page quite easily. I also got the link down here, which I will put in the chat in a couple of minutes. All right, so what I'm going to do now, I'm going to grab my camera because I've got a portable laptop with my camera, and it will be Will Oldham who will introduce himself and give you a brief tour of the INB building. So I need to set up a bit, grabbing my camera, grabbing my laptop.
Hey guys, yeah, we see some questions there right now. Max Lewis says, is university better than CCNP for getting into the workplace? CCNP, is this for networking, network security stuff, Max?
Yeah, it's CCNA, I think.
Right.
I think university gives you a more rounded experience. CCNA is very focused, isn't it, on very particular parts of networking and network management and so on. You can do CCNA certifications as part of your university studies with us here.
Yeah, one thing I would say is that there's more opportunity for doing a more diverse range of things that will make you more, how would we say it, make you more suitable for different jobs. So you've actually got a broader range of skills at the end of it. So things like we've been doing Azure training stuff recently. So the different Azure fundamentals courses and things like that. We're likely to do a lot more of those. So yes, you can do individual courses and pay for them. They tend to be quite expensive as well, which is a bit weird. But university, as Mark says, is more of a broad spectrum kind of thing. You have a bit more support from your peers and those kind of things. So it's a different approach to getting a job, I think. So Matthew Flanagan says, "Why are you wearing a mask indoors?" It's because there's somebody else with him, Matthew. So obviously, you don't want to have people in close contact.
All right, guys. Microphone working? Everything good?
Yep, we can hear you.
Yep.
Excellent. So I've got Will Oldham here. Hello.
Hello, my name is William. I am the third year computer science student. I'm also the school representative for the School of Computer Science. My role within the school is to listen to all of the feedback from students across the school and help use that to shape the experience that you have at university. Alongside myself, I work with a team of representatives that work with individual year groups and individual courses, whether that be computer science, gamers computing, one of our postgraduate offerings. And we collate all of that feedback and make sure you're getting the absolute best out of your time at university. So what we're going to do now is we're going to take you for a quick tour around the Isaac Newton building here that we have on campus, which is the base for our maths, physics, engineering and computer science courses. and we'll give you a little tour around. So the first thing we'll go and have a look at is our amazing lecture theatre. Now this lecture theatre can fit up to 500 students at once, which is really good, and it's a really amazing facility for us to have. So we will just pop through these doors now, and hopefully there's no one in here that we're going to interrupt. Which there isn't. So this is our fantastic 500-seat lecture theatre, complete with screens on the board so everybody can see the presentations that are going on by lecturers and academics that come and teach it. This lecture theatre is also used throughout the year, probably more in non-COVID times, of course, for guest lectures that we have for the School of Maths and Physics. We have some really good, great guest lectures that come in here. Now we'll go and have a look at the atrium and the labs.
Cameron, we will get to your question after we'll study it, so thank you.
Good. There we go. Okay, so yeah.
Sorry about the dodgy camera work there. Obviously, trying things live. So, Cameron, yeah, you're not too late. I don't know whether you know this, but like the university system is pretty flexible in terms of these things. So, definitely apply still.
Yeah, you can apply right up until September. If you've got any specific questions about applications, though, it's probably best to speak to the admissions team at the university. I think you'll get you'll be able to speak to them on today as well. I think there'll be somebody here today. If there's any specific questions about admissions and how the process by which you apply and so on, but the school or the college that you're at should be able to give you some feedback in terms of what you need to do and by when.
All right, I've returned.
Oh, no, he's not. This is a live broadcast. How many students are in each course? It's kind of hard to tell right now because of the impact that COVID's had. But it's more about how many are in each cohort and the class sizes rather than the overall program size.
The issues of broadcasting live. Hello, everyone. I've returned. Microphone's working. Mic check, quick. Everything's working?
Yeah, it's working.
Yeah.
Fantastic. Thank you, everyone. Sorry for that. Again, the issues of broadcasting live were portable. So thank you very much for, bearing with me, even though I did dry run this a few times.
Yeah, Julie, we'll get to your question in a bit after Oliver's just taken us through the building.
So just over the first floor balcony here, you can see our wonderful atrium. This has a cafe, and it's a general study space for any students that come and work here. And this is not just computer science or any of the engineering students or anything like that. Any student across the university can come and use this space to eat, drink, work. And it's generally a nice study space to work in. Along the top floor corridor, we also have a bunch of seats as well for people who want to come up and work. So there is plenty of space around this building to actually come and work in, which is really great for us. Now on our left here, we have one of our smaller labs, and this is one of the labs that has been newly outfitted with our beautiful new RGB computers, which are rocking lovely new Intel processors and all new 3060s and 3070s. So this has been a really big upgrade for all of our labs, and we can't wait for students to be able to come in and use these. So this is a project that's going on over the summer in all of our labs. We've got probably around 5 main labs in the school, and these will all be upgraded with these beautiful PCs. And if we just come through to this other lab, you'll be able to see this was propped open. This is one of our other labs. This is one of the main labs that's in use. This is also a lab that's used primarily for game development as well. And so this lab is going to have a complete makeover over the summer to that purpose. And you can see in the background the whole crates of computers that are taking part as part of the upgrade. And so these are going to be distributed throughout the school. And we're going to become a really amazing resource to be used for all of our students here. Now, traditionally, in times where coronavirus hasn't existed, our labs have all been 24/7 access, so the students can come in at any time, computer science students that is, and use the computers to do their projects, do their work. And it's a really great resource for this school to have.
Yeah, Cameron, normally they're open 24/7.
Yeah.
All right, thank you very much, Will. That was fantastic. Little brief tour of our INB building, of basically the main facilities of the School of Computer Science. Of course, we didn't show you all the lecture theatre because there's plenty of rooms that you can use. There's also other facilities, there's other buildings as well. So I really recommend to book a tour and come to the campus and see for yourself. Of course, until restrictions are lifted, you can't visit the inside of the INB building. That's why we're giving you a quick tour of what it looks inside. So, of course, if you've got any questions about the building itself or anything else, feel free to ask us in the chat. But for now, we're going to continue this virtual open day with Mark Doughty, who's going to talk about computer science.
Oliver, should we get to some of the questions first? Because there's a few.
Yes, sorry, it's a bit tricky for me. Let's have a look at the questions in the chat. So,
Julie, I think, was the one we got up to. So, Julie, how many students are on each course? Well, I think in the first year, probably for games, Phil, about 50 or 60 is what we've had in previous years. For computer science, you're talking 150, maybe 200, 250. It depends on the on the level of applications and so on. And really, we can't predict that at the minute. It's very difficult for us to do that. But generally, computer science is a bit bigger than the games cohorts. Matthew, the lessons still online or are they in person? So last year everything was online. This year most of it will be in person. Most lectures, workshops and so on will be in person. There will still be some online, and those are sessions that we felt work particularly well online as opposed to face to face. So you'll probably find that there's a mixture, leaning towards more face to face.
Yeah, I've preferred not having like really early lectures with hundreds of people in one room kind of thing. So what we've done a lot of online kind of delivery and flip learning for that.
Matthew, this is probably one for you, Phil. Can we do gaming on the machines, on the computers?
Yes. That's actively encouraged, obviously, for the games program. But to be fair, computer science guys do games as well. So, yeah.
One thing to remember though.
Can I remove the RGB? Yes, you could probably switch it off. Put it that way. Another one was, have we got a networking lab? I believe we have, haven't we, Mark?
Yes, on the second floor, so the floor above the one that we're on at the minute, there's a lab that is dedicated to networking. So it's got a lot of networking hardware, switches, routers, and various bits and pieces that you do as part of your course here, but also which will be used for things like CCNA certification, which is what I think we mentioned earlier.
Yeah, I mean, some of this stuff is like an ongoing refurb process for a lot of the PCs that have been replaced and are being replaced. So it's kind of an ongoing process. And the networking stuff is being enhanced because of that. Max asks if it's possible to see the networking lab. Oliver?
Yes, we can. You'll just have to give me a minute for me to go upstairs, if that's okay. So you guys can answer.
Yeah, shall I do my bit? Start doing my bit on computer science while you're, or do you want to leave it until afterwards?
Give me 2 minutes. There's a few more questions you guys could answer whilst I'm walking upstairs.
Okay, Cameron, how long are normal university days, and how many days a week is it usually? That's difficult to answer because you are a full-time student if you're enrolled on a full-time program, so you should expect 5 days, Monday to Friday, but in practice that probably won't happen. There'll be a mixture of that. It depends on which workshop you're allocated to and so on. But some of the days I'll talk about this in my bit coming up. There'll be lectures and workshops on a particular day with big gaps in between where you can work or you can do other things or whatever. So you should be looking at 3 or 4 days, I think, with face to face or taught commitments, I think.
Yeah, the traditional day that we don't we have a half day on Wednesday afternoons that we don't schedule students for, so they can do sports activities and clubs and stuff like that. So that's the only day that's generally off limits.
Yep.
So the idea is that you should plan to be available for any of those 5 days, but the actual sort of results depend on the timetabling, so we can't necessarily tell you. And it changes obviously every term, every year. The one thing I will say though is that a lot of if you're going to do it right, if you go to university, you want to spend more hours doing your work than you would it's a different way of developing things. So if you really want to get into industry, you have to start sort of doing that practical side of things, and that needs a lot of time working on things. So even if you're not necessarily in the building, a lot of the time you'll be working on, like if you're a game developer, you'll be working on games for yourself, and that's a really useful exercise to do.
Hello everyone again. Yep.
In terms of raw hours. Hey, Oliver.
Sorry. Hello, sorry to interrupt. Yeah, I'm currently in the networking labs, and we do have a couple of racks, for instance, networking racks behind us. Not sure if Will is able to talk about them because he hasn't done. Oh, you have.
Yeah,
you have. That's fantastic.
Yeah, so we've got a variety of network racks here, and this whole room is custom built to actually fit in with these racks. So if Oliver looks at the setup for the PCs here, you'll see we've got the normal PCs on the top, but under the desk, we actually have special PCs which are networked into these racks. And essentially in these racks, we have switches and routers, and so students can connect the computers below the desk, and they connect them to the routers and the switches, and they can do all sorts of the configuration stuff required for any of the networking programs that we do, including the certification.
That's fantastic. Thank you very much, Will. Hope that answers the question about showcasing our network lab. So thank you very much.
So we've got a few more questions, Oliver. Julie asks, it's been a while since I finished school and I went straight into work in the film industry. Do you think this would have a negative impact on my application? No. To be fair, we kind of encourage people to apply from non-traditional backgrounds anyway, Julie, just because you can never really tell. The point is that we need to be sort of allowing people to participate in education from a wider, more diverse background. So it always helps to apply anyway, and just see if the actual program is appropriate for you, really. So I definitely encourage you to do that.
Yeah,
and
I think Julie, rather than have
worked in an industry gives you specific skills that that there are things like APL where we can give you credits for the skills that you've learned, that kind of thing.
Yeah.
And so Matthew asks, to be a teacher, do you have to have a previous job in the industry? Have you had any real job experience? Yeah, I came from the games industry, Matt. I spent 14 years working in the games industry. I've still actually been developing games while I've been a lecturer as well. So, yeah.
Myself as well. I'm teaching a lot of programming. I've been in the industry programming, website stuff and other algorithms, but I'm still in contact with the games industry at the moment, working on upcoming titles. Well, not fully full time, but helping in my spare time.
So yeah, I've been at the university for quite a long time, but before that, I was a teacher in schools, in secondary schools, and before that, I worked in a bank on their IT side. So yeah, it's quite you'll find with everybody in the school, all the academics have got varied backgrounds. Some are pure researchers, some are very practical, some have recently come from industry, some have got a mixture of industry and academic experience. So you'll find a broad range.
And there's Phil's favorite question popped up.
Yeah, well, weirdly enough, Oliver, I mentioned this, but a game I worked on recently called Ground Branch just got published by a publisher called Microprose. But before that, I worked for a company called Team 17 for a decade, working on the Worms games.
Yep, that is fantastic. Should we move on? Of course, guys, if you've got more questions, feel free to pop them in the chat. We'll answer them after the presentation, or me and Mark and Phil, answering them in the chat. So let's move on with Mark talking about computer science.
Yeah. Okay. So yeah, hello everyone. I think a lot of what I was going to say, I think some of it has been answered already by the questions and so on. But I'll go through this anyway, and we'll see what we come up with. So my name's Mark Doughty. I'm the program leader. So I deal with all the academic stuff to do with the program. So all the modules, all the assessments, and so on. On the other side, you'll have your own personal tutor, which deals with the personal side, how you study, your life outside the university and whatever. So it enables the university to sort of help you in that way. So we hopefully try and cover all bases. So as Oliver and William said, we're based in the INB, which is this new building here. So it's home to not only the School of Computer Science, but also the School of Engineering, and the School of Maths and Physics. And it was purpose-built. Certainly the grey part was purpose-built only a few years ago. And you've already seen some of our labs, and they were built specifically with computer science in mind. On the left, so you see various buildings as part of the campuses for the University of Lincoln. So the campus is made up of a number of large buildings, each one pretty much looking at a specific school or a specific faculty within the university. Okay, so why should you choose computer science? Now, hopefully, if you're looking at this, you probably thought computer science is for me. But it is something which I would say, I'm sure that a lot of computer scientists would say, that everybody should do. It teaches you how to think. It teaches you how to treat things logically, as well as giving you vital skills in programming, software engineering, network management, and so on. It enables you to address some of the major problems that we're finding starting to become more and more prevalent in the world today. So things like pollution, climate change, poverty, overcrowding, health issues can all be addressed by computer science in terms of, or can all have solutions which contribute to their alleviation with a computer science theme. So you taking part in a computer science degree will hopefully lead on to bigger things where you're looking at some of the problems which come about as part of some of these issues. On your course on computer science here at the University of Lincoln, what can you do that will actually help you to move towards generating solutions for those areas? Things like robotics, artificial intelligence, vision, computer vision, so machine learning, which is a hot topic at the minute, software engineering, programming, which is one of the core disciplines of computer science here at Lincoln, things like cloud development, cloud computing, and so on. All of those are delivered as part of the course here at Lincoln in computer science. There are others, of course, so things like networking, cybersecurity, network security, virtual reality, network games development, games design. All of those can form part of your studies, hopefully, which will then you can, as we'll talk about in a second, you can tune your course through options later on. So what will you study? So you study, if you're looking at the traditional BSc, for 3 years. In your first year is really about consolidating. There can be a wide range of abilities and experiences that come into this program. So what the first year is really about consolidation. It's about looking at programming. Some people haven't programmed before, and some are very experienced. And it's a case of trying to bring them together. So we look at programming fundamentals, where we use Python. We look at basic mathematics for computer science, maths for computing, problem solving, which is a key element of computer science, and things which are much more specific. So things like object-oriented programming with C#, algorithms, program and system complexity, architectures, and so on. And from that, you can then move into your further into the program by looking at more specific and advanced things like programming, networks, database, cloud computing, AI, and so on. Your final year is where you can really start to tune your experience by choosing options, which really sort of represent or can help you to sort of move this program in the direction that you want it to go in. As well as doing that, you have a major project that you do as an individual project. Those options that you can choose really depend on how you want your career or how you want your interests to go forward. So things like graphics and VR, AR, and so on. Or you can start to look at things like cybersecurity, network security, robotics. If you're interested in the mathematical side of computer science, so things like logic and computation, the theory of programming and system development, and so on. So there are a number of options which can help you sort of guide your program, really. Oh, right. So a typical week might this isn't a specific week. It's one that I've sort of over the last couple of years. This is sort of a typical sort of thing that you might do. So you might have a lecture on a Monday, workshop. You might have lectures on a Tuesday, a workshop on a Wednesday morning. Wednesday afternoon is, as Phil said earlier, is reserved, and things like sports clubs, societies, and which really contribute to your experience of university, and it's not just about the academic side, it's about the social side, the development, your own personal development by taking part in clubs and societies and so on, and broadening your interest. Thursday you might have a personal tutor meeting, so you might go along and meet your personal tutor and discuss how you're getting on and so on. And Friday you might be free, so you may be able to use the library, you may be able to use a computer laboratory and so on. So you could be doing stuff pretty much most days of the week. Okay. So when you say lectures and workshops, what do we mean by that? So a lecture is pretty much what you would experience if you were in school or college as a class, basically. So the lecture will be, as we saw earlier, in maybe that lecture that we saw earlier, or in smaller ones around the campus. They're usually around 1 to 2 hours in length, and they're pretty much used to convey information, for you to sort of make notes. Their sessions are normally recorded for you to go back over in the future, and so on. It's an opportunity then for you to take notes, ask questions, discuss, and so on, with the rest of the class and with the academic. Well, the workshop, on the other hand, is a much smaller. It's based in the laboratory, which we saw earlier, and it's really about you trying to practice, or you practicing what you've seen in the lectures. So you're given tasks, you're given problems to solve. We can use the computers in the workshop, or you can use your own. So you can bring your own device. These workshops are timetabled, but you can also use the workshops, as we saw, outside that time as well. So there is a mixture of lectures and workshops. So what can you do while you study? So you can, certainly at Lincoln, we offer Microsoft certifications in Azure and cloud computing. But we also offer, I think we mentioned that earlier, and we answered the question on things like CCNA. So we offer a CCNA certification program as well that you can take part in. So we give you the opportunity to use the equipment and go for the exams and so on. There are also organised development events that are organised by the Computer Science Society, so things like the Global Game Jam, which I'm sure Phil might talk about later. There's different hackathons, 24 hours, 48 hour sort of development activities and so on. Facilities, as we saw earlier with Oliver and William, there are too many to mention. There are computer labs, a number of computer labs with a large number of computers, but also as well as that, there are bits of hardware that you can use as part of your modules with your project, your own developments and so on if they're free. So things like Raspberry Pi, Arduinos, hardware boards and so on, VR headsets, mobile devices, robots, robotic kits and so on. So all of that is available for you to use. So as part of your program, after your second year, you'll some of you may wish to go on placement. So we offer placements. So we don't offer placements to everybody purely because of numbers and so on. But it's really a personal choice. So over the last couple of years, people have spent time in the university with the NHS based in Lincoln, or in other trusts with the civil service, with Siemens, and various other organisations. And these are only the computer science related placements. On the game side, I'm sure Phil will talk about there are a number of other areas that you can secure placements with as well. Placements are usually 12 months after year 2, fully supported by us. You're visited by an academic and so on. But you can also, if you don't wish to do a 12-month placement, a summer placement, 2 or 3 months over the summer, and it means that you can complete your degree in 3 years. So that's my quick whistle-stop tour of computer science. I'm sure we've answered many questions anyway. We've addressed some of these issues, but we can certainly go back over some of the questions if that's yeah. Chocolate Skull says, I was wondering if it's best to have your own device. Yeah, so it's good to have a device. It's good to have your own laptop or whatever, which so it enables you to study outside normal time. So it means you're not reliant on the machines in the workshop, the computers in the workshops in the labs to help you study. It means you can study in your own time. So a laptop is a really useful thing to have. Spec of the laptop can be there's no recommended spec.
I would leave off on purchasing right now because the prices are likely to come down fairly shortly as things like graphics cards and stuff become more available again. But in general, having your own PC is definitely a useful thing to be able to work with other people. What I have noticed is that quite a lot of students also have external hard drives for storing things when they want to take it home from the labs and that kind of stuff. So it is useful to have your own equipment for sure. Yeah,
so we also encourage the use of the university has, or the students and the staff within the university have use of cloud storage as well. So it enables you to store information in labs and access at home, but also you can do that with other things as well. Things like GitHub, which a lot of our modules encourage you to use Git and so on.
Yeah, Max asked about should I get one with a GPU. My recommendation would be definitely, because even if you're doing computer science, it will still be useful for things like machine learning if you take those modules. But just in general, you'll find that laptops with like decent GPUs will actually be the more powerful ones anyway. So it tends to be that if you get a reasonably spec laptop, you'll probably have a GPU in it as well.
Bearing in mind, I think you've got this laptop then for 3, maybe 4 years. So it needs to sort of be able to, I suppose, sort of cope with the rigors of what you might do 4 years ahead. Or 3 years ahead or whatever. So.
Yeah, I mean, the thing is that obviously the labs are available to you, so it's not like you absolutely have to do that. But I think that the students I've talked to always seem to sort of prefer, well, the ones that use laptops seem to really, really like being able to do that. So it's kind of it depends on how you want to work, right? If you want to be able to work on the move, or if you've got a commute, or if there's anything where you need to be that flexible. I mean, things like doing game jams and stuff is really useful to be able to have a laptop and bring it in with you. So it does depend on your own circumstances quite a lot and the way you like to work on things. But you don't have to have one.
Yeah, the computers in the labs are regularly wiped and refreshed. So instead of customizing a machine in the labs, it pays really to do that on your own laptop and have something which is yours basically. And in the labs, those machines or the computers in the labs, you can't rely on those to be exactly how you want. Okay, so Phil, I think it's over to you.
Yep, thank you. Okay, everybody. So my name's Phil Carlisle, and I should probably go to my slides. So my name is Phil Carlisle, and I'm the program lead for games computing. And I've been a professional game developer since I was, 20-something, which is a long time now. I'm not going to say how long, but a long time. So my background is as a games programmer, and I've worked on primarily artificial intelligence stuff across the games industry on a number of titles. Most recently, actually, I did a game called Ground Branch, which I just saw got a publisher last month, which is really cool. But I've worked on startups in London, games across a bunch of different platforms, loads of different technologies. And the one thing that I've always been really interested in is the sort of content production side of things. So a lot of my research is about that, working on next generation technologies. So things like Unreal Engine 5 and that kind of thing. So what's games computing? What is it? How is it different from computer science, and why would you study it? Well, the way I try and sort of talk about it is that games computing is basically computer science, but with a focus on the games industry. So with a focus on, well, actually more the creative technologies industry right now. And so what we're doing is we're studying the more interactive graphical side of computer science, really. And what that usually means is that we're dealing with aspects of design, but also aspects of technical content and things like, low-level programming for performance, things like real-time systems and that kind of thing. So what it actually is all of the sort of fundamentals of computer science applied to a particular industry, and the industry itself is generally termed the creative technologies sector. So the reason why I keep bringing up this sort of creative technology thing is that the creative industries in general, I think it's the third largest sector in the UK economy. So there was a thing that came out a couple of months ago about how big each aspect of the economy is in the UK terms, and the creative industries, which is basically games, film, TV, streaming, all of that kind of stuff, in general, is the third biggest sector. And if you think of that creative technologies and you add on like general software and technology and ICT and that kind of stuff, we're actually the second biggest as a group part of the economy, apart from finance. So what I'm saying is that it really is a significant part of the UK job market and the UK economy and the way that it contributes to it. So one of the things that I get a lot of the time is parents asking, why would somebody want to go and work in the games industry? And I keep saying it's because it's a big business and there's lots of jobs and they're very high paying tech jobs. So just to give you an idea of the kinds of things that I'm talking about, there's a company called Epic Games, which if you're a game player, probably already know about. Epic Games did the game Fortnite, but they also do a lot of technology and development for the games industry. And they just had a funding round, and they were valued at just over $17 billion. And this is basically a games development company. They're not massive, but they're not small either. They've got something like 7 different studios now. But the point is that is just a games company, right? So you can think of this multiplied by the number of games companies in the world, the sort of reasonable size ones, and we're talking about a significant sector. And what that is it's driven by the need for technology for basically sort of content production. And that's, that's one company, right? So we can look at their direct competitor. And again, I actually saw 2 different figures for this one. So this is Unity, which is like, there's 2 sort of big players for like game engines right now. And Unity is their opposing number. It's a bit like Coke and Pepsi, right? And Unity were also valued at, actually I saw a different figure. I saw 17 billion, but I saw another one here on VentureBeat, 13 billion. So the point is that they're multi-billion pound companies that are basically developing technology for not just the games industry anymore. And that's an important point. So when we're talking about developing games, don't think of it as just games. Think of it as technologies for the creative sector. So this is a slide that came from Microsoft a few weeks ago. And what you can see is that almost all of the big technology companies, so Amazon, Microsoft, even Facebook, weirdly enough, are all putting lots and lots of investment into gaming as a sort of media platform, because they see that it's actually becoming more and more part of people's everyday media consumption. So if you want to sell things to people, basically, you have to be able to be into games and have an audience of games and those kind of things. So what we're seeing is that the sector's actually changing quite a lot. So what's happened traditionally is that the TV industry is starting to adopt a lot more of the creative technologies that we've been using in games for a long time. And so what we're seeing is a lot of crossover in there. So why would you study games computing in particular? And my general sort of appeal to you is this, right? It's because there's loads of interesting things to do in it. it's not like you have to sort of think of it as one thing, right? It's not just about making games. It's also about thinking about interesting aspects of interactivity. So what will you do if you study games? Well, the main thing you'll do is you'll make a lot of games. For the most part, games as a field is practice based, right? So we expect you to create a lot of games, and a lot of them will be bad, but that's how you learn things, right? You learn by doing for a lot of it. So what we'll give you is lots of opportunities to develop games and give you feedback on how to develop your skills in creating them. So a lot of it is about you trying new things, maybe failing, trying again, and eventually sort of gathering the experience and the skill to develop anything that you want. And the idea is that the reason why I got into games is because I love the idea of imagining something and then being able to create it. And that's what games can do for you. So the important thing is that the skills that we learn doing this aren't just used in the games industry. I wanted to sort of highlight a few of these things. So if you go on to the Unreal Engine webpage, again, the URL here, this is the technology that underpins the Fortnite game. But it's actually, you can get hold of the source code for it, and you can actually build it yourself. It's available in lots of different industries, and this is an example of the Unreal Engine page where it talks about, where would we use that technology, and it's got things like film and TV, automotive, transport, broadcasting, and live events, which is really interesting, doing things like live streaming and concerts and those kind of things. But even things like architecture, right, where you want to be able to do virtual and augmented reality simulations of different buildings and that kind of thing. So it happens that the techniques that we learn developing games is available to a broad range of industries. And what I've been seeing a lot more of is that there's a load of recruitment into these areas that aren't traditionally games as well. And so what you'll see is that, there's jobs at, say, like the BBC for a game engine programmer or game programmers, game developers, game designers to work on content for TV and film, for instance. And that's a really interesting thing that's relatively recent. In the last sort of maybe 3 years, it's become much more of a thing. So I think it's worth thinking about that. You don't just have to have a career in the games industry. You can have a career in TV, film, virtual production, all of those kind of things now. So my job is to keep abreast of the games industry, right? Keep abreast of the technology and the things that are going into these different industries. And you've probably seen, if you're interested in games, there was an announcement probably about maybe 4 to 6 weeks ago. The guys at Epic released their next generation engine in early access. And you can see that there's lots and lots of new technologies that are going to come along and change a lot of these industries I've been talking about. And Unreal Engine 5 is definitely a good bellwether for that kind of thing happening. And so what we really want is for you to become a skilled practitioner, not just in one technology, but to be able to adapt yourself to new technologies as they come along. Because the reality is that what is current now probably won't be in the next sort of 5 years. So what you need to do is get the skills to be able to learn new things quickly, adapt to new working practices, and generally just be a really good programmer. And that's what the industry wants to hire, really. They want just good programmers that are like capable of adapting to different languages and different platforms and different requirements. And those things tend to change all the time. Certainly in my experience, I've worked on loads of different platforms with loads of different capabilities and with different languages. And it's kind of a thing you need to be able to do all the time. So just to sort of highlight a few of these different industries, this is the scene from a set on the TV show called The Mandalorian that Disney did. And you can see in the background, there's like sort of what we call a virtual production set. And what it is there's a bunch of LED panels that are displaying the results of a game engine as the background so that they can then film it in camera. And the reason they do this is so that you can capture all of the sort of lighting details from the background without having to go out on, basically in the middle of a desert, and the cost involved in that. So this thing called virtual production is relatively recent, but it's become much more widespread in the TV industry. Obviously, the pandemic's made that a lot more viable, or certainly a lot more useful to developers. And so the skills that you learn for doing Unreal Engine in games, again, is becoming much more valuable in these kind of sectors. I see a lot of jobs in that area as well. So what will you study on game development? Well, I try and think of it in a different way. So that we can obviously talk about individual modules if you're interested. But what I would say is that the first year, the idea is that you're learning to program, and this is for computer science as well. We expect you to learn to program in the first year, right? So you'll learn the basics of programming, and in the games course, you get a little bit of games design, game studies stuff to give it a gamesy flavor. But for the most part, it is introductory programming in year one. And then in second year, it's more about learning to program games specifically. So this tends to become more specialized, and things like working in a team. So there's a bit more games specialism in the second year, and we have things like games programming as a module. And then in the third year, what we're looking at is allowing you to choose your specialism. So you actually choose what you're going to do in your third year, more in terms of your own projects and your own interests. So you learn to program in the first year, you learn to program games more in the second year, and then in the third year, you learn to specialize in the features that you want to program. So things like, if you're interested in networking in games, you might specialize in that for your project. You might choose that as options. If you want to do machine learning or virtual VR, that kind of thing. So it tends to be that we go from the sort of general to the more specific as you get closer to the going out into the industry, basically. So this is the idea, right? That we allow you some more optionality in the third year, so you can choose how to tailor your portfolio to the job that you want at the end of it. So for the most part, it's about self-directed study in the third year, so that you really get the most out of and create the best portfolio. And the games industry is very much about building a portfolio of good, high-quality, finished games as a thing for your recruitment. So the one thing I will say is, if you're thinking of games, our program specifically is about games programming. So it is very much about that sort of technical side of things. It is a very challenging program. It's not about playing games. If that's some people think that they'll come on a games course and somehow it'll be about playing them, but no, it's very much about making games. And so there's a very different mental mindset you need to have for that. But I will say that it is really very rewarding, and it's a lot of fun to be able to make games, because it is that idea that you take something that you imagine and you create it, right? These things don't exist. There is no natural game that ever existed, right? So what we do is we make up these things in our mind, and then we transform those into the artifacts of games. And that's a really powerful thing creatively to be able to do. So what you really need for a games computing student, ideally, is that enthusiasm to be creative, but also an interest in the sort of technical side of things as well. So Mark mentioned sort of placements, and I will say that placements are really hard to get in the games industry, but they're very, very useful. So there's a good example of a guy who went out to Rare, which are owned by Microsoft, and he's just finished his third year and he's going back to them. So placements are definitely a thing that you can get in the games industry, but they tend to be very picky. So it is obviously there's lots and lots of people who want to do those kind of things. So it is very much you have to show that you're better than everybody else, which is obviously hard. But So we do help you getting placements, and Sam's a great guy. He'll help you try and find a placement. We'll support you while you're doing it. And it's definitely a thing that if you can get into a placement, it's very, very much encouraged. But again, they tend to be very, very few of them in the games industry for some reason. Just to mention our teaching, we were TEF Gold. I don't know whether TEF is still actually a thing. Obviously, the pandemic has changed quite a lot of teaching. But what that meant was that we were regarded as the sort of highest band of teaching quality back when this was the sort of main focus for the government. And I will say that we do try and be really good at mentoring people. Now, obviously, not everybody agrees with that all of the time, but that's what we really want to be able to do, right? We want people to come out with not just the degree, but also with a really good sort of positive view of their time at Lincoln. And so that's what I really want you to sort of get across, is that it is about sort of attitude a lot of the time as well. So you'll find that we're very open as lecturers to, you know, helping you with things. So, so your placement would be between year 2 and 3. Obviously, the careers service helps try and find these kind of things. There are internships as well, but they tend to be a little bit shorter in term. So a lot of them, things like play testing and stuff tend to be internships, which are not always the best in terms of job opportunities, but they're good experience at working as a games company and those kind of things. So they tend to come over the summer as well. Again, it does depend on the time and whether the companies are working on projects and when those projects are in development. So we can't really predict those kind of things. But what I will say is that we do try and make a lot of the fact that the university is, we want you to be doing things all the time, right? We want you to be making things all the time because it is a practice-based discipline. So things like game jams and hackathons and taking part in student societies is an important part of your being a student at the university. So we do things like the Global Game Jam, but of course the main thing is that a lot of these are student-led. So we want students to help each other, like, practice things, right? So the best thing you can do is take part in that community. It is a community of development. I mean, I still make games both commercially and for fun, and I expect my students to do that kind of thing as well, right? So we want you to participate in the creation of stuff. There is a game development society. There's a computer science society as well, and we expect, you know, we want people to take part in those things because it just helps everybody practice more. And that's what is important for games, at least. And obviously there's a gaming society for actually playing games if you're interested in playing them, but, you know, I'm interested in making them as well. So if you've got any questions, obviously you can get in touch with us all. I'll put my contact details in the chat, or I'll get Oliver to do that. We will be around for questions, but if you've got any questions at all, obviously you can get in touch with us. You can get in touch with me through the staff information, or Oliver will give you my contact details. But certainly, please let us know if you've got anything that you want to know about. We're always happy to answer questions, even if it's just general knowledge questions on game development. That's fine. So I shall stop sharing my screen, and we can hopefully have a quick chat and just see if there's any questions. Hey, Oliver. Oliver's not got his headset on. Yeah, so there was a question. Looking forward to... not a question, I suppose. A statement. Looking forward to starting in October. Umar? Is that right, Umar? I can't see my text is tiny. Are you starting on computer science or games computing? Would you say it is a learning by doing course in regards to both computer science and games computing? For games computing, well, no, for both, to be honest, yes, Julie. It's all about getting hands-on and making things. And you know, don't be too scared of things not working the way you want, and actually getting the skill of being able to sort of persevere in the face of things not quite working. It is very much a practice-based discipline, you know.
Yeah, I think, as Phil says, there's lots of opportunity in workshops and in your own time and with societies and stuff to practice what you've seen as part of your program, but also other things as well. And I think, as Phil has said, the more practice you do, the more you become aware of, and the more you develop. We definitely encourage people to practice and to actually do what we talk about.
Yeah, the other thing is that it's really useful to think of it as a sort of peer thing, right? So you develop something and you can teach somebody else how to do that, and they can develop something else and teach you how to develop it. And the idea is that you learn together by, trying something new in a different area that somebody else hasn't tried, and you teach each other that way. And that's, honestly, the games industry is really brilliant for that. Like there's very few barriers to allowing people to learn new things. And I always love the games industry for that kind of feeling that there's no exclusion. Like everything I've learned, I've generally learned from other people doing things. I've learned from tutorials. I've learned, and I do that kind of thing myself, right? I teach other people how to do it because that's how we all learn. That's how we all improve.
Yeah, your university isn't just a one-way experience. It's not us telling you what to do. It's us learning for you. You've all got different experiences and backgrounds, which can contribute to what happens at university, but also between you and your peers as well. So it's a complete experience, I think, and one where we encourage this sort of this learning to happen in all directions.
Yeah, Julie, to sort of make a sort of argument for your case, right? I started learning virtual production sort of late last year, sort of just to learn a bit more about how we would use Unreal Engine and the game sort of technology in the film and TV industries. And it turns out that it's really interesting, right? So I've been learning a lot about cinematography and film and TV work, both from our research, but also just in general for the program. And that's new to me. And obviously I can teach that to the students. I can teach that. I can get people in from the industry, from that particular industry, and we can see these new opportunities. And that's why I think it's really fascinating. It could be that you're really interested in a particular thing, and all of us are really interested in board games, and he can bring that enthusiasm for that particular thing into the university, and we'll discuss it with students. We'll talk about different designs, and that's why I think university is useful. It's not just about the things that you're taught in a program, it's also about the things that you discuss outside of it as well. It's kind of like it's the enthusiasm for doing new things, I think.
It is indeed. For instance, you mentioned Magic Work board games, which when you're game students, in my opinion, there's no way to avoid playing a board game, especially now. We are in a golden age of board games and card games. There's plenty of them coming out every few weeks with a brand new approach of how to deal with statistics, how to deal with game mechanics. And those are very interesting to investigate, to research, and then perhaps take parts of the gameplay and then transfer it into a digital version. It's actually very interesting as a games designer to not just look at digital version, but also to look at what's happening on pen and paper. So I'm very passionate about board games.
He is definitely very passionate about board games. Yeah, I mean, I'm so to give you an example of why it's kind of important to not think of it as a silo. I spend most of my time these days working on machine learning for video games. So I actually do much more machine learning programming than I do like traditional games programming, because it's actually going to transform lots and lots of different industries, and it's actually transforming the games industry a lot as well. So I'm trying to understand the parameters of that And it's those kind of things, right, where you pick something you're interested in and you go and pursue it. That's what university really should be about. So the idea of you get to the third year and you've really tailored the study to what you're interested in personally. And that is the thing that we try and enable.
I think there are quite a few sort of areas which transcend the two disciplines of games and computer science. So things like programming, network management, cybersecurity as well is something which has become more prevalent in the games industry, protecting networks and so on. So I think that there is a lot of synergy between the two programs, and we see that with the common modules and so on, but in the wider area as well, I think.
Yeah, it's important to not be put off by. Here's the thing, right? Even if you're not taught things specifically, like if you're not given a module in a particular thing, there's nothing stopping you from investigating it anyway. I would certainly encourage people to go and look for things. And again, during your time at university, it's a time to be able to look for new things that are interesting to you. So it could be that you go and attend a lecture on a completely different program, like psychology or heritage, or, you know, loads and loads of different events are happening throughout the university's timetable. And there'll be a lot this year, you know, you can guarantee it. And I go to them randomly, and just sometimes they're really, really interesting. So I went to one, and I think there was a guy from NASA, or no, so it was JPL, sorry, the Jet Propulsion Lab, and he was talking about doing the telemetry for the lunar landers and for all of sort of the things that land on different planets and how they do the positioning of it. And it was really fascinating stuff. And this is, you know, this happens all the time. I went to a lecture randomly a couple of years ago. I think it was David Packham, one of the guys that is like popular in biology, I think it was. And he was just talking about a particular, I think it was like a fungus or something, you know. But the point was that it was fascinating to just sit and learn about something that isn't necessarily your direct area of expertise, and just think about how it might impact you, or just in general for your own interests. And that's what you can get at university, right? You can actually spend time looking at things that just interest you. And I would definitely encourage everybody to try and do that if they're going to take 3 years to study.
That's fantastic. All right, having a look at the chat, there's no more questions, which is fantastic. So that means we did a great job answering all the questions, everything that we wanted to cover. So unless there's any more requests or any more questions, I think we're going to finish this virtual open day. So thank you very much, Phil. Thank you very much, Mark. I've put all our contact details in the chat. I've put Mark's contact details, I've put Phil's contact details, and my contact details. Also, I put the link towards our YouTube page, but since you guys are watching this on YouTube, so it's actually pretty easy to find. So have a look at what we've got on our social media. Have a look at our other lectures, our other virtual open days. And of course, if you've got any questions or stuff that pops in your mind that you're not so sure about, feel free to send us an email, and we'll reply as quickly as possible / arrange a one-on-one virtual chat with you. Otherwise, that's it for today. Thank you very much, Phil. Thank you very much, Mark.
Thanks,
and
everybody.
guys, I'll see you all in October. So see you, Mark. See you, Phil.
All right.
See you.
Bye-bye.
See you all. Yeah.
See you,
Bye then.
everyone.
See you, everybody.